Okay, so we're going to take a look at this worksheet. I didn't mention in class, but it says right here on the top, scientific calculator only, because you will not get to use a calculator. Actually, I don't think we'll even need a scientific calculator on the quiz. I'd probably allow it, but we will not be using a graphing calculator on this test. Okay, so number one, axis of symmetry, we're doing the negative b over 2a thing. So our a is 1. There is no x term, so b is 0. And then c is the 1. So a is 1, b is 0, c is 1. So for axis of symmetry, I do negative b over 2a. So in this case, it's negative 0 over 2 times 1. So we end up with just 0. X equals 0 is my axis of symmetry. In the vertex, we take that 0 and we plug it in. So we get 0 squared plus 1. Well, that ends up being just 1. So for my table of values, I'm going to jump to my table of values. I can put that right in the middle. Actually, I could go, yeah, let's go ahead and do this. It might be affected by my y-intercept. My y-intercept is the c value. So you might notice I already have that. The vertex happens to be the y-intercept, so that I won't put that on the table. So I'm going to actually truly surround 0. 1 and 2, negative 1, negative 2. So if I plug in 2, 2 squared is 4 plus 1 is 5. Should be symmetric. Negative 2 squared, if you put it in parentheses, is in fact positive 4. Plus 1 is positive 5. So it is symmetric there. 1 squared is 1 plus 1 is 2. And negative 1 squared is also 1. Plus 1 gives us 2. Okay, so we see we can go ahead and plot our picture there. The max or min, well, the vertex is at the bottom. We could have known that since a was positive, we knew it was going to open up. So the vertex is at the bottom, so it has a min. What is that min value? It's whatever the y value is of the vertex, which was 1. Okay, number 2, my a value is negative 2. My b value is 4. My c value is negative 3. That negative 3 is your y-intercept. Technically, I guess I could be saying 0, negative 3, and 0, 1 over here. But I want to do negative b over 2a. So negative 4 over 2 times negative 2. Well, that's negative 4 over negative 4. So we get x equals positive 1. Plug 1 in. Okay, so negative 2 times 1 squared plus 4 times 1 minus 3. 1 squared is 1 times negative 2 is negative 2. Negative 2 plus 4 is 2, minus 3 gives us negative 1. So 1, negative 1. Since my a value is negative, I know this one's opening downward, so my vertex is at the top, which is the max, and that max value will be whatever the y part of my vertex was, which is negative 1. Okay. So my y-intercept is different than my vertex this time, so I'm going to include that on my table of values. Since 0 is 1 unit away from 1, go the other side of 1, the vertex, we get 2. It should have the same y value, should be symmetric, 2, negative 3. And so then I can also go one further, negative 1, positive 3, plug one of those in. If I plug 3 in, 3 squared is 9, times negative 2 is negative 16. Oh, sorry, 18, I was added 9, not an 8. Once again, that was negative 2 times 3 squared. 3 squared is 9, negative 2 times 9 is negative 18. Plus, plug in 3 here also. 4 times 3 is 12. So negative 18 plus 12 is negative 6, minus 3 is negative 9. Should be symmetric. I think I did that right. 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah, okay. Oops, I crossed a little early there. Shouldn't cross that negative 1 until I get down to my point. There we go. That looks good. Now we get into the factoring. Factor completely. The first problem, or number 3 here, they both have an x, so I factor the x out. Leave me with x plus 4. That can't factor any further. I'm finished. This one, two terms, they don't have anything in common, but they are perfect squares. This is the square of 3x, this is the square of 8. So difference of two squares, 3x plus 8, 3x minus 8. If you didn't keep up with that, I would encourage you to go ahead and distribute this or FOIL this out. 3x times 3x, 9x squared. 3x times negative 8 is negative 24x. Here we get positive 24x. Those cancel. And then 8 times negative 8 is negative 64. Okay, number 5. We've got an a value. So multiple ways to do this. If you do it my way that I showed you, take your a times your b. That's negative 60. I'm trying to come up with two numbers that multiply to negative 60 that add to negative 4. It's going to be a 6 and a negative 10. They add to negative 4, they multiply to negative 60. So I'm going to leave the first term alone, and then replace the negative 4x with a 6x and a negative 10x. So positive 6x, negative 10x. Together they make the negative 4x. And then keep your last term by itself. Now factor by grouping. Those first two and then the last two. First two, I can pull out a 2x, leaving me with 2x plus 3. These two, I can pull out a negative 5, leaving me with 2x, positive 2x, and then negative 15 divided by negative 5 is positive 3. Both sets of parentheses match, 2x plus 3 in both cases. So now I can factor out 2x plus 3, leaving me with, pull it out of the first term, I'm left with the 2x. When I pull it out of the second term, I'm left with negative 5. So that is now factored. You could do this one by grouping as well. I wouldn't. We just need two numbers that multiply to negative 10 that add to 3. So we get a negative 5 and positive 2. Doesn't matter which set of parentheses comes first. Okay, number 7, a times c. 2 times negative 21 is negative 42. So I need numbers that multiply to negative 42 that add to negative 11. Let's see. So it's not 1 and 42, 2 and 21, no. 3 and, what's that, 17? No, it's not 3 and 17. What is it, 3 and 14? Yeah, 3 and 14, that'll work. Okay, so I went negative 14, positive 3. They add to negative 11, they multiply to negative 42, there we go. Negative 14x, 3x. It doesn't matter which one comes first. It's going to work both ways. And we'll end up with the same answer of it ultimately. So factor by grouping, I can pull a 2x out of each of those, leaving me with x minus 7. And then I can pull a 3 out of here, these two, leaving us with x minus 7 also. So they both have x minus 7. So pull that out front, and then I'm left with 2x plus 3. Okay, number 8. There's no lead coefficient, so I'm looking for two numbers that multiply to 16 that add to negative 8, and it's negative 4 and negative 4. Since it's the same factor twice, I'm only going to write it once and write that it's squared. Here my AC is 60. Need two numbers that multiply to 60 that add to 19. It's not 6 and 10. Let's see. 3 and 20, 2 and 15. So one is, maybe I should start thinking, I should go in order. Sometimes if you have to look at it for a second, you're going to start getting lost. So I'll just kind of go through. 1 and 60 are not going to work. 2 and 30 are not going to work. 3 and 20 are not going to work. 4 and 15, there it is. You want to multiply to a positive and add to a positive, so they're both positive. So I'm going to have a 4x. I'm going to have a 15x. Grouping. I can pull out a 2x, leaving me with 5x plus 2. These two pull out a 3, leaving me with 5x plus 2. They both have a 5x plus 2, so I can factor that out. Leaving me with 2x plus 3. Right, number 10, a times c, 3 times negative 28. negative 84. And I need to multiply it to positive 5. Let's see, trying to think through in my head what's going to work. 8. So once okay, 184 is not going to work. 2 and 42 is not going to work. 3, I don't think it's going to work either. It's 3 and 28. That's not going to work. 4 and 21 is not going to work. Let's see. 6 and 14. We got close. 6 and 14. Yeah, so we need a 5. Okay, so that's not going to work. 7 and 12. There it is. 7 and 12. We need the 12 to be positive and the 7 to be negative. They multiply to negative 84. They add to 5. So 3x squared, and then I'm going to have a positive 12x and a negative 7x. Grouping. I can pull out a 3x. We move x plus 4. Here I can pull out a negative 7. Leave me with x, and negative 28 divided by negative 7 is positive 4 also. So x plus 4 in both cases, leaving me with 3x and minus 7. Okay, now with number 11 we get into the solving. So factor and then go ahead and solve. Here I'm going to need a negative 7 and a positive 4 for my factoring. So I need to multiply to negative 28 and add to negative 3. Now set each factor equal to 0, so x minus 7 equals 0, and x plus 4 equals 0. We get 7 as an answer, and we get negative 4 as an answer. And number 12, it's a difference of 2 squares. There's only 2 terms. It's subtraction. 64 is a perfect square, so it's x. So use your special factoring pattern, x and x, and then it's a plus 8 and minus 8. Set each factor equal to 0, set x plus 8 equal to 0, set x minus 8 equal to 0, solve them both. We get negative 8 and we get positive 8. So I could just say plus or minus 8. The 2 answers. Up here we've got an a term, so AC, 5 times 6 is 30. Even to multiply to 17, looks like that's going to be a 2 and a 15, both negative. Negative 2 times negative 15 is positive 30. They add to negative 17. So 5x squared, I've got a negative 2x, I've got a negative 15x, and then my plus 6 equals 0. Grouping. Now I can pull an x out of both of those, leaving me with 5x minus 2. I can pull a negative 3 out of both of these, leaving me with 5x minus 2. They both have a 5x minus 2 factor. That would take that out, leaves me with x minus 3. Now set each factor equal to 0. 5x minus 2 equals 0. X minus 3 equals 0. Add your 2. Divide by 5. I get 2/5. This one you just add 3, so you get positive 3. So 2/5 and 3 are the solutions there. Number 14, before I jump into the AC thing, I notice that all of them are divisible by 3. So I would factor 3 out first. That's going to make it a nicer problem. X and x. I need 2 numbers to multiply to 3, add to 4. That's a 1 and a 3. Set each factor equal to 0. Technically 3 is a factor, but it doesn't equal 0. So I ignore that one and I go to the x plus 1 and the x plus 3. Set them both equal to 0 and solve. I get negative 1 and I get negative 3. Right, let's go to the back page. Word problems. All right, so we're charging money for an aerobics class. 70 people attended it when it cost $20. We're trying to maximize revenue. I'm talking about increasing the price. They're talking about $1 increases in price. We started at 20, we're adding $1 at a time, X number of times. That's what this expression right there is. That's the price of the class. But for every $1 increase, we expect to lose one customer. We started at 70 customers, so I'm going to subtract 1 X number of times. So that's number of customers. When you multiply the number of customers times the price, you get the total amount of money, or the income, they're calling it in this case. So income equals customers times price. So part A, what price should they charge to maximize the income? Well, I'm going to want to go ahead and graph this. Well, sorry, it says you can use graphing calculator, but I retract that statement. I just told you you won't be using a graphing calculator on this one. So I want to find the maximum, or I want to find the vertex without using a graphing calculator. So it's a little more work, but I would start off by multiplying these together. So 70 times 20. 70 times x, negative x times 20, and then negative x times positive x is negative x squared. We're trying to find the y-intercept. No, sorry, I take that back. Never mind. Don't worry about what I just said. So let's go ahead and solve combine like terms. I'm also going to put it in descending order. So negative x squared. Combine like terms, I get a 50x. Plus 1400. The a value is negative, so I know it's opening down, so the vertex is at the top. It is a maximum. We're going to try and find that. So we would start with that negative b over 2a thing to find your vertex, or your axis of symmetry. So negative 50 over 2 times negative 1. So negative 50 over negative 2, that's positive 25. So for my vertex, I've got to plug that in. And what that tells me, that to get to my vertex, the x coordinate should be 25, and x, remember, is the number of $1 increases. So we should increase our price by $1 25 times. I actually can stop right there because I know the answer to part A, and then I'll have to figure out what part B is. So the maximum, what I should charge, the price, 20 plus x. X is 25. So 20 plus 25 gives me 45. I should charge $45 to maximize my income. So what is the income if we actually did do that? Well, that's the y part of our vertex. I can go ahead and find the rest of our vertex, or I can, I'm going to end up plugging it in is what I'm going to do. So I'm doing 70 minus 25 times 20 plus 25. I can plug it in here, or I could plug it in this negative x squared plus 50x plus 14. It doesn't matter. They're going to give me the same answer. I kind of like this idea here. 70 minus 25 is 45. 20 plus 25 is 45. So I'm charging $45 a piece for 45 people. Let's figure out what that is. 45 times 45. You can do that on a scientific calculator if you're not sure what it is. And we get 2025. So that's the maximum income. That was the question. So we will be doing this problem without a graphing calculator on the quiz. But it's really not much different than what we did on the front page when we found a vertex. Number 16, the length and width of the 6x8 photograph are reduced by the same amount to make a new photograph whose area is half the original. Well, the original, we could show two different pictures. 6x8, that's 48 square inches, was its original area, was the original. The new one, same dimensions, just smaller. It's going to have half the area. So instead of 48, we're going to have 24. We're reducing it by x. So instead of 8, this is going to be 8 minus x. Instead of 6, this is going to be 6 minus x. But its area is 24. So area is found when you take length times width. So its area is 24. We can go ahead and distribute this. Combine like terms, and also put it in descending order. X squared minus 14x plus 48 is equal to 24. Now I want to set it equal to 0, so I'm going to subtract 24 over. Now I'm going to factor this. Looking for two numbers that multiply to 24 that add to 14. And looks like it's a -2 and a -12. So solve those both. X minus 2 equals 0. I get positive 2. X minus 12 equals 0. I get positive 12. So 2 and 12 are my answers, but I don't know that they both make sense. So remember what we're doing with x, we're subtracting that from the actual dimensions. It was previously 6 by 8. I can't subtract 12 from 8 and have a -4, and subtract 12 from 6 have a -6. That doesn't make sense in the context of the problem. I can, however, subtract 2 to get a 4 by 6. So the question is, what is the value of x? X was 2. That was the only one that actually made sense in that problem. Number 17, they give us an equation. So we don't have to create that. H is the height, t is the time. How long is the boulder in the air? Well, the boulder is going to be in the air until it hits the ground. So I want to find, it's going to be something like this. I don't even have to graph it. No, it started with it at, I guess it, okay, crosses here. That's, going to be something like that. We know it's going to be a picture more or less like that. How long is the boulder in the air? Well, it's in the air until it hit down here. Where does it hit there? Well, when it has a height of 0. So I can set my height to 0. So it's like a factoring problem. It looks like I have something I can factor out of both terms. I think I can pull out a -16t, leaving me with t, and then I have 240. 240 divided by -16. Actually, I want to pull out an 8, not a 16. I was thinking 16 went into 240, but let's pull out a -8t, leaving me with 2t minus 30. Sorry. I typed it in the calculator, I typed it in wrong. So it would have worked. Sorry for the confusion. Let's go back to what I initially said. We can pull out a -16 from both of them. -16t. So we're left with t minus 15. Now, to solve this, we set each factor equal to 0. So we can set -16t equal to 0. You can set t minus 15 equal to 0. Solve them both. And this one you divide by -16, you get t is 0. This one you add 15, you get t is 15. So at time 0 and at time 0 seconds and 15 seconds, it's touching the ground. Well, it makes sense that it's touching the ground at 0, because that's where it started. 15 seconds later, it's touching the ground. So it went from 0 to 15. That's 15 total seconds that it was in the air. Part B, what is the maximum height? So now we'd like to find the vertex of this problem. So here we can go back to this -b over 2a. We have a 0 for a c value, by the way. So -b over 2a, if I want to find the vertex. 240 is b. -16 for my a. So I get -40, 240. Over -32. Negative over negative is going to be positive. 240 over 32 is 15 halves, so it's positive 15 over 2. So 7.5 seconds till it gets to the height. So that actually answers part C. How long did it take to reach the maximum? Well, 7.5 seconds. Which makes sense if you think about part A. It took 15 seconds for it to hit the ground, so half of that time, 7.5 seconds, is when it would have been at its maximum height. So now we can plug 7.5 in to figure out the actual maximum height. So it's -16 times 7.5 squared plus 240 times 7.5. Plug that in your calculator. You can have a scientific calculator. So it's not that you have to do this all in your head. Just won't be able to graph it to find the answer. We get 900. So 900, we're talking feet, yes. That would be the maximum height to go all the way up to 900 feet. So then the question is, what time did the boulder reach a height of 515? Well, to answer this, your height was 515. I put that in the height part, the h sub t, and then the equals the equation. Well, to solve this, we're going to probably solve it by factoring. I'm going to have to subtract it to set it equal to 0. This is going to be a kind of a not fun problem to use factoring for. If I didn't have to, I would never use this approach, but if we don't have a graphing calculator, it's really our choice. It's our only option. So let's do the AC, negative 16 times negative 515. That's really exciting that we get such a big number, 8240. And I'm trying to come up with two numbers that multiply that to make 240. So I might actually start making a list. Um, 8240 is not divisible by 3. But if I divide it by 4, I get 2060. I still, if I'm thinking about it some, what those numbers add to, sorry, I forgot a 0 in there, 2060, 2060. So if I add those numbers together, I'm still not even close to the 240, so I got to keep going. Is 8240, it's not going to be divisible by 6, should be divisible by 8, 8 and 1030, still not going to add to the 240. How about 16? Yep, 16 and 515. No, how about I guess a 5. I could have divided it by 5 as well. How about like 20? I'm probably skipping some here. 20, 412, no. It's not divisible by 25. How about a 40? 40 and 206 there. I think we might be getting close. We're trying to get a 240. Okay. So 40 and 206 will add to 246. It's close. Oops. Just trying some options here. You're definitely going to use a calculator for this one. Oops. What I might do, I'm having a brain fart here, so I'm going to, instead of wasting more time, what I'm going to do is make a factor tree. I can see all the possible numbers it could be. Could have been a 10, but I don't think that would make sense. That would have been still too big. 20 I tried. 40 I tried. 16 times 5 could have been an 80, but let's see what that is. 103. We passed the 240. I'm wondering if maybe this question doesn't even work well without a graphing calculator. That's a possibility. Maybe it was made with the intention that we were going to use a graphing calculator. So let me cheat. I know that you will, on the quiz, if we're not letting you use a calculator, we'll make sure that it's one that will work, and it will work better than this. Okay, so I'm going to graph change a window. Okay. Okay, so I'll show you my calculator. It's graphing. I guess I need to go out farther yet. My X max go out to like 20. I think 15 would have been enough, but I'm going to go that far. So let's check what these intersections are. My guess is that they're not very nice ones, considering I'm having trouble finding the factors, or maybe I just missed it for some reason. But if I want to go to calculate my intersection, this first curve, I'm going to approach this left one. Yep, so it's not a nice number. About negative, it says, I can't read that very well, but negative, or not negative, sorry, 2.59. That's why we're not finding it on this graphing or the factoring. Let's try that other intersection. So now we go to calculate, intersect is the fifth option down. I'm going to go over and approach that other. And we get about 12.41. So approach there, the 515 like 2 times on the way up and the way down. How did I graph this? If you're not sure where this came from, I'll go to my y equals. I plugged in the original equation, and then I was trying to get a height of 515, so I just typed in 515. That gave me the 2 graphs that I'm looking at, finding the intersection of. So I guess you can disregard all of this work down here, although that's what you would have to go through if we're without the calculator. And so that one didn't work out. We figured out it wasn't nice answers, but so be it. Yeah, so okay. That's the end of the worksheet. So that's all there is.